Now let's discuss missing data in Pandas. The way in which Pandas handles missing values is constrained by its reliance on the NumPy package, which does not have a built-in notion of NA values of for non-floating data points, data type, sorry. So Pandas could have followed R's lead in specifying bit patterns for each individual data type to indicate nullness, but this approach turns out to be rather unwieldy. While R contains 4 basic data types, NumPy supports far more than this. For example, while R has a single integer type, NumPy supports 14 basic integer types once you account for available precisions, signedness, and endianness of the encoding. Reserving a specific bit pattern in all available NumPy types would lead to an unwieldy amount of overhead in special casing various operations for various types, likely even requiring a new fork of the NumPy package. Further, for the smaller data types, such as 8-bit integers, sacrificing a bit to use a mask will significantly reduce the range of values it can represent. NumPy does have support for masked arrays, that is, arrays that have a separate Boolean mask array attached for marking data as good or bad. Pandas could have derived from this, but the overhead in both storage, computation, and code maintenance makes that an unattractive choice. With these constraints in mind, Pandas chose to use sentinels for missing data and further chose to use 2 already existing Python null values. So the special floating point NaN value and the Python none object. The choice this choice has some side effects, as we will see, but in practice ends up being a good compromise in most cases of interest. So now let's save the file by the name missing data in Pandas. So now let's discuss none, which is Pythonic missing data. So the first sentinel value used by Pandas is none, a Python singleton object that is often used for missing data in Python code. Because none is a Python object, it cannot be used in any arbitrary NumPy or Pandas array, but only in arrays with data type object, that is, arrays of Python object. Import NumPy as np, import Pandas as pd. Now vals 1 p dot array vals 1. So this d type is equals to object means that the best common type representation NumPy could infer for the contents of the array is that they are Python objects. While this kind of object array is useful for some purposes, any operations on the data will be done at the Python level, with much more overhead than the typically fast operations seen for arrays with native types. For d type, and now int colon print double quotes. We'll use double quotes. D type D type time it and p dot a range. Now in the bracket 1e6 d type equals to d type bracket close dot sum double parenthesis print parenthesis. Now it will give you the result after some loops. So the sum of Python objects in an array, which means that if you perform aggregations, okay, so aggregations like sum or min minimum across an array with a none value, you will generally get an error. Like vals1 dot, we get an error, as you can see that unsupported operand, there's a type error, unsupported operand types are type for plus integer and none type. So this reflects that fact the addition between an integer and none is undefined. Now let's discuss NaN missing numerical data. The focus of the topic will be missing numerical data. So the other missing data representation, NaN, acronym for not a number, is different. It is a special floating point value recognized by all systems that use the standards IEEE floating point representation. NP dot vals2 dot d type. Notice that NumPy chose a native floating point type for this array. This means that unlike the object array from before, this array supports fast operations pushed into compiled code. You should be aware that NaN is a bit like a data virus. It infects any other objects it touches. Regardless of the operation, the result of arithmetic with NaN will be another NaN. 1 plus np dot NaN. Now NaN 0 np dot NaN results in NaN. So note that this means that aggregates over their values are well defined. That is, they don't result in an error, but not always useful. Vals2 dot vals2 dot vals2 dot we got the result, but we got documentation, nothing to worry about. So the NumPy does provide some special aggregations that will ignore these missing values. np dot then sum vals2 np dot NaN dot so keep in mind that NaN is specifically a floating point value. There is no equivalent NaN value for integers, strings, or other types.